Forbes called it the oil of the 21st century, and a lot of people are very optimistic about it, even describing it as the priority area for a sustainable circular economy. But is this really true? Could this be the new liquid gold everyone should be hyped about? If you haven't guessed it already, we're talking about hydrogen, and in specific about clean hydrogen. Hydrogen is the most abundant element in the universe, present in water and nearly all living things like plants and animals. Hydrogen is classified by color spectrum, yet in this video 3 different colors will be highlighted. First, we have gray hydrogen, which is currently the most produced type of hydrogen. It is produced from natural gas. This method emits significant amounts of CO2, making it in general an unsustainable option. Then we have blue hydrogen, which is basically gray hydrogen, but the carbon emitted is captured and stored in the carbon capture and storage system. This method does not devoid all CO2 due to its 85 to 95% CO2 capture efficiency. Lastly, we have green hydrogen, which is produced through the electrolysis of water, which splits water into O2 and H2. The energy comes from renewable energy sources such as wind or solar power. The whole process emits no CO2, making green hydrogen the most sustainable option. There are certainly reasons why you should focus on hydrogen. In recent years, many environmental problems have arisen due to the large consumption of fossil fuels as energy sources. Clean hydrogen has emerged as an important option to reach these targets. In practice, hydrogen can be used for 3 things. It can store a surplus of renewable power when the grid cannot absorb it. It can help decarbonize hard-to-electrify sectors such as long-distance transport and heavy industry. And it can replace fossil fuels as a zero-carbon feedstock in chemicals and fuel production. Hydrogen is easily transported as energy across diverse geographical regions through pipelines and liquid fuels, and its long-term storage capacity in tanks or underground reservoirs makes it the only single energy transformation technology to store it throughout the year. Hydrogen is mostly used by heavy industry, transport, buildings, and for power generation. Currently, the majority of hydrogen production comes from fossil fuels. Several nations are promoting blue hydrogen, which is a less expensive alternative to green hydrogen. They consider it as an economically viable and realistic technique for lowering CO2 emissions. Yet, critics argue that blue hydrogen is just a way for fossil fuel industries to keep on drilling. They argue that the hydrogen industry is heavily lobbied, as a network of lobby groups, PR firms, and consultancies are funded by oil and gas companies. An example is the Hydrogen Council, which members consist of companies such as BP, Shell, and ExxonMobil, who certainly have specific interests. This results in the funding of projects that exacerbate climate change and lock in our reliance on fossil fuels for decades. Hydrogen is therefore a masquerade for fossil fuels companies to greenwash their businesses, whilst also continue their practices. To make matters worse, a study by Howard and Jacobson showed that emissions from blue hydrogen compared to grey hydrogen are only 9 to 12% less compared to the 85 to 95% claimed. They even found that direct use of fossil fuels emits less greenhouse gases compared to blue and grey hydrogen. Still, one can argue that technologies will improve and that blue hydrogen can serve as a bridge to full green hydrogen adoption. Another problem hydrogen faces is its conversion efficiencies. System inefficiencies can lead up to 80 to 90% loss of the initial electrical energy input. Yet, some people still see the value, as an overload of renewable energy can be stored in hydrogen. Today, green hydrogen faces challenges in cost and infrastructure, but there are also other challenges. Suppliers will not make large investments as there are no customers, whereas customers will not rely on hydrogen as there is no reliable supply. Would this mean that hydrogen will never develop? No, not really. Renewable power faced the same problems, but had to rely on policy interventions. One of the companies that relied on policy interventions is Netstek, as they received a subsidy for almost 22 million euros by the Dutch government. Netstek is a Dutch company focused on green hydrogen and it's building the biggest fuel cell plant of Europe. Fuel cells convert hydrogen and oxygen into electricity. The new factory is expected to increase their output from 10 megawatts in 2021 to 1,000 megawatts in 2027. Yet, they were found bankrupt this year, as they were unable to pay their debts. Fortunately, 2 companies took over Netstek and made reorganizations to make sure the plant could be finished. The story of Netstek emphasizes that clean hydrogen projects are still not economically viable. Still, different countries are increasing their investment in this clean energy. Hydrogen still has a long way to go and certainly has some positive and negatives. The question now is, what would be the best way to use hydrogen, or should it even be used?